Hello, welcome to our webinar. I'll go over some housekeeping items while people are joining us. Today, you're here for the Investigating Magnetic Fields webinar that will be presented by the one and only Dave Vernier. We'll be doing some introductions a little bit later, but I did want to let you know that we'd love to answer your questions throughout the webinar today. We have Tom Smith in our Physics and Engineering Tech Support Department helping us to field questions in the background. Feel free to use the chat or the Q&A option. We'll be monitoring both of those. We also have some additional resources for you in a shared Google folder, and I'll be adding that to the chat, and you can that will have the link to the folder and the resources of the experiment and sample data. We'll also be recording this session. If you'd like to view it afterwards or share it with a colleague, I'll be sharing that link in the chat closer to the end of the webinar. So our agenda today, you're going to meet Dave. We're going to do introduction to Graphical Analysis Pro and our GoDirect sensors that we'll be using today. We'll go over some options for remote education, some of our resources that you can use in person or remote settings or even hybrid learning environments. And then Dave will be doing a live demonstration of Graphical Analysis Pro with the magnetic field sensor with a Slinky. And then we'll have some time for Q&A. Again, if we happen to not get to your question, we will follow up after the webinar. So this is Dave Vernier. He has 12 years of experience teaching high school physics and physical science. And he and his wife, Christine, founded Vernier Software and Technology 40 years ago. So it's our 40th anniversary this year. Again, a little bit about the webinar, Q&A. Feel free to ask questions. We'll be answering those. Dave will be talking in a moment a little bit more about graphical analysis and Graphical Analysis Pro. So if you wanted to play along with him or have an interactive experience, you're more than welcome to go and download GA. But this is a short session, so we wanted to give you the option if you just want to view the presentation, that's totally fine. So I am going to turn it over to Dave.
Thank you, Angie. Glad to be here. This is only a half-hour presentation, so I'll go pretty quickly. And as Angie said, you're welcome to join in if you can, or you can just choose to watch it. Remember, you can also see the recording later. I'm doing this workshop using graphical analysis, and I can't resist telling the story of the history of it. I wrote the first version for Apple IIs really started writing it in 1981, which is 40 years ago, hence the anniversary thing. And our company started then. But you can see that has an ad there with graphical analysis for sale on Apple II cassettes or diskettes. And that's me teaching back in those same time period. Next slide, Angie. But fortunately, graphical analysis has come a long way. In fact, we're very proud of what we've got now. It's a program that's available on Windows, Mac, Chromebooks, iOS, and Android, which with a similar look. So it's really great. You can have kids using a mix of platforms, and you don't have to write special instructions for each one. And that's free, the graphical analysis. And then we have a subscription service to something called Graphical Analysis Pro, which adds some neat features. I'm going to show some of those. And it's really relatively inexpensive. And the good news is we make it simple. You don't have to have a different password for every single kid, or you don't have to keep an exact tally of how many students. It's one price for every student and every teacher in the school, including their home devices and the school devices, whatever. Next slide, Angie. So I'll just say a word or two about this year we've just gone through. As you know, it was quite a year for everybody, but for us, it was in March. We thought we were in pretty good shape. We had great solutions for teaching in a physics lab or a chemistry lab or biology lab. But we've always, for all the 40 years, been all about hands-on science education. And frankly, we hadn't done that much about remote teaching. So when the pandemic hit, we really did try to jump on and do some things to help teachers who are in this terrible situation of having to teach science remotely. And I'll show a couple of those today. I mentioned just briefly this first one. Um, the we first we went through. We have about 24 books of science labs. We went through as many of those as we could think of and published results. Good results from as if you had done the experiment. And we offered those free on our website. They're still there. I think we're going to leave them there till the end of the summer. And it's better than nothing. If you had to be in a remote situation, you could at least give kids some results and have them do some analysis and stuff. So that was our first step. And then we started adding things to Logger Pro, graphical analysis. And I'm going to show two of those right now. They're listed there. We'll do one part of this. This is a two-part lab we're going to be doing. We'll do one part with the live data sharing, and the other part we'll do with an experiment file. So next slide, Angie. Just a word about the experiment. It's lab 26 in the Physics with Vernier book, this book right here. And there's versions for all kinds of platforms, but we're doing the version we're using graphical analysis. And next slide, Angie, our magnetic field sensor is a 3-axis magnetic field sensor. It's in the GDX family of sensors. We have about 45 of them now. They're pretty cool sensors. They connect by Bluetooth or they can connect by USB. And they have a built-in battery and rechargeable and all that stuff. Okay, I think I might take over presenting now, Angie. Thank you. Slinky. So this lab is the magnetic field of a slinky, which is a solenoid, right? So, but it's kind of fun that you can use something that kids are familiar with for the experiment. So, so I'm going to present my screen and show you what we'll do here. Let's see. All right. How's that look? Do I have the Zoom thing there still? Do you see a Zoom thing? Oh, there we go. Is that right?
Good, Dave.
That's good.
Okay. So notice on the, what I'm going to do in this workshop is kind of try to have a split personality thing where the teacher view is going to be here and a future, when we get a student involved, the student view will be over on the right side. I've got graphical analysis running. It's the free version. I can tell because of that thing right there. Look, we call it a shield. And that will be there if you have the free version. Now remember, anyone can download this. Every student can download it on their phone. They can download it on a computer at home or an iPad or whatever. But if you want the full-blown features of Graphical Analysis Pro, you need to upgrade it. And I'm going to do that now. And the way you do that is you go here and to the About screen, and you type in a license key. Now, in the real world, a normal world, you as a school have either bought a Graphical Analysis Pro or maybe you have a 30-day preview. You get a code, a secret code like that you can type in, and you have one for your school. Now, for the purposes of this workshop, we're going to use this code right here. I know they're a little hard to type, but if you want to join in with me, get your graphical analysis going and type in that number. But I bet Angie's going to put that in the chat for you, and that can save a lot of time. I also have it copied here somewhere, and I'll paste it in because it'll save me time, hopefully. Right, yeah. But you can type it in. It's just a little bit tricky to get the upper and lower cases. Okay. Now I'm going to close that and notice that something's changed. The shield is no longer there, and we have this thing here. We call that the data sharing icon. Now, I'm going to now get ready to do an experiment. Let me just do new experiment here real quick, just to clear the screen. And say new sensor experiment. I've already got my magnetic field sensor connected. I did that earlier. But now if I want to do an experiment, this is what we're going to demonstrate, what we call live data sharing. And the overview of what we're trying to do here is I will do an experiment and collect data, and that data can be transferred to any student anywhere in the world, as long as they're on the internet, who has the same code and has a copy of Graphical Analysis Pro. So we're going to go through the process here. I have a student, Tom Smith, who's a great tech support person here at Vernier, his former physics teacher. He's going to play the role of a student on an iPad, and I'm bringing it's called Air Server image of his iPad over here. Let me make this a little bit smaller so you can see it all. Well, make it smaller over here and bring it. So the idea is you'll see on the, one side his view and one side my view. And if you want to play along, you're welcome to do things. You'll be doing basically what Tom does. But first I've got to get set up for this experiment. And the way I do that is I go to this, remember the button was called data sharing button. I'm going to go there and look what's happened. We've generated a code, and this is a different kind of code. This is a code just associated with this particular experiment, which I would give to all the students who are going to join in on this experiment. Did you get that, Tom?
So I see it on my screen over here.
Oh, let me show you this feature. This is kind of cool.
So I can go, I'm going to hit the sensor data collection button.
Actually, you want the data sharing button.
Data sharing.
So Tom should go and choose new experiment and then data sharing and type that number in.
How am I doing so far?
Good. All right, now an interesting thing has happened. You might notice his graph has changed to magnetic field, which is like mine, which is just kind of interesting, but shows something's happening. Now, we're in a position where I'm connected, I'm the teacher, he's the student, and I'm just going to do a quick thing that's just kind of something to do, but I'm going to take, hit the collect button, and I've got a permanent magnet here I'm bringing close. And the interesting thing, as you would expect, I'm seeing data on my graph, but notice it's also appearing on his graph almost instantaneously. So that's what we call live data sharing. Okay, now we're ready to do the experiment. I'm going to actually set up for doing it's a two-part lab, as I mentioned before. The first part is about, it's all about the magnetic field of a slinky, but in the first case, we run current through the slinky and measure the magnetic field as we vary the current. So let me set up for that. I'm going to do new experiment. Don't save. Tom, you got to, now, do sensor data collection, yeah. Now notice something happened on Tom's screen too, the student over here. Since I started a new experiment, he's got to decide whether he wants to quit and go play baseball or something or join the experiment. So he should join. And notice his screen clear too. Now, this experiment, you have the instructions for it, you have the teacher's guide for it, but to give you a quick overview, I'm going to show an image of the setup. This is a different camera kind of above us. You can see we have a power supply, which somebody's going to adjust. And then we have wires to a slinky, which is used as a solenoid, I mentioned, and it's a metal slinky. Don't use a plastic slinky. And we're going to measure, as we change the current, we're going to measure the magnetic field. Now I have to put the magnetic field sensor in position. I have at the 50 centimeter mark, I placed it, and I've got it on a little box so that it's about the center of the solenoid. Okay, now I'll get rid of this. Maybe I'll just make this smaller, Tom. I think I'll get it. Yeah, maybe I'll temporarily get rid of it, but this experiment, if you follow the instructions, there's two things I have to do in kind of a preliminary way. I mentioned before that the magnetic field sensor is a 3-axis magnetic field sensor, and it is, and the way it's set up is the x-axis is down the shaft of the thing, and the y-axis is right angles to that. Now we want to measure the magnetic field down the slinky, so I'm going to uncheck X and check Y. Okay. And there's one other thing I want to do before we really start. We live in a world with the Earth's magnetic field, right? And we also have like tables and metal things which have magnetic fields. So I have to zero that out. So I'm going to hit, right? If I click right here, I can choose 0. So that should subtract away. And I'm going to do a couple other things. I like to have a meter displaying the reading here. And I also like to have a data table. So this is typical graphical analysis stuff. You can turn on and off these features. I've got the screen small, so this is a little crunched, but we'll show the idea. Okay, I think that we're running pretty well and ready to go on this experiment. What do you think, Tom?
So I'm feeling like I may need to restart my experiment.
Okay, go ahead. You want to do data sharing? Now we might need that code again.
It's in the chat, so I can just.
Well, I hope it didn't change. It shouldn't have changed.
Yep. So you can see the data come in real time. I think it kicked off because we changed the channels. That's my guess.
Oh, really? I didn't know that. Okay. Okay, now you're there. Let's see, I might resize your screen again just to make it prettier to see. Remember, this is really an iPad screen just projected by AirPlay. Okay, so one more thing I need to do. I need to change. The last experiment I did was like most physics experiments, where you just click collect and the sensor takes data at a regular interval. But this particular experiment is what we call event-based. In this experiment, I'm going to let the magnetic field sensor measure its thing, but I'm going to type in the second thing, the current. And the units are amperes. And we'll read that from that power supply display. If you don't have a power supply with a display built in, you can use an ammeter in series with the circuit. Okay, in events with entry mode, they call it selected events. Yeah, events with entry, they call it. Here's the way things go. You hit collect, and this keep button becomes highlighted. And we won't take a reading until we hit the keep button. So what's the current there, Tom? Let's see. Let me bring this in so we can show that. What's the current there?
Reading 0 right now.
All right, 0. I'm going to hit a keep, and I'm going to type in the current, which is 0. Now, if you read the instructions for the lab, what it asks us to do is increase the current by about 0.5 amp each time and just go all the way up to 2 amps. So, Tom, if you don't mind, Tom's now, he's kind of playing 2 roles. I had him playing the role of a student who could have been anywhere in the world, right? Now he's right here in the lab helping me, but.
So I put it at 0.53 amps.
All right, so I'm going to say keep and say 0.53 amps. Now, notice something interesting. If I get my camera out of the way here, I have a point there and a point there. How about you, Tom? Tom has points too. I noticed something, Tom. I've got a data table and you don't. I think, frankly, it would make this experiment more interesting if you could see the numbers, but I can't do that for you. It's up to you. You see that, and this is a feature of the program. The student is in charge of what happens on their screen, things like what's displayed and curve fits and stuff like that. So I would suggest you turn on the data table on your screen.
Okay, so I'm going to hit the view icon at the top of the screen and choose data table. And that shows up at the bottom.
All right, good. It'll make it a little more interesting as we proceed. You ready to move to another current?
Sure. So there's 0.97 amps is what I ended up with.
All right, I'll say keep. 0.97. Keep. And I guess we can go all the way up to 1.5 or something close to 1.5.
There's 1.47.
Keep. 1.47.
And we go on up to 2. or
Close to 2, yeah.
1.99 amps.
Keep 1.99. Now, we've really followed the instructions pretty nicely here, and I'm going to hit stop. And Tom, if you don't mind, since I can't see your points very well, would you mind doing the thing where you display point protectors around them?
Oh. Well, Dave, I don't know about point protectors, so I'm going to learn something today.
Okay,
How
click
do I
on
go
the
about
little icon at the bottom left corner of the graph and choose edit graph options.
Okay.
And then see that thing, appearance, choose both.
Oh,
Oh, wait, but that's line. Oh, I'm sorry, I'm mistaken. That's not what we want. I don't, well, we could do that. That's a point-to-point line. Maybe we should just do the points. It may be the way we should have it. Okay, I guess I was on the wrong track. There is a way to do that, but that's not it. Okay, so at this point, we've collected the data for the experiment, and if I'm the teacher, of course, the student should have the instructions. I would be inclined to say, well, students, you have the data now, and follow the procedure in the rest of the lab and handout, and put your report in tomorrow.
There is a question in the chat that
Yes.
we might want to address. There's, can we go over again how a student would join this session?
All right.
They figured out how to start a data sharing session, which is what you did. But in order to join, maybe I can just drive since I'm the student.
Okay, I'll tell you what, let's, should we close your window? Let's see, how do we do that exactly?
Well, I'll just start a new session and join again. So
Okay, well, here, you want me to do an experiment, a new experiment, and you'd have to join again? That would work. So just to wrap this up while we've got the data on the screen. So I could do a curve fit course on my side. In fact, I will right now, but notice something interesting. If I do a curve fit, it's obviously linear. I'll apply that. I have a lovely curve fit on my graph. Tom doesn't have it. And that's by design, because we want Tom to have to do the curve fit and things like that. In this experiment, he should get the slope and the permeability of free space and stuff like that. It's all in the explanation. But we think it's a feature that the student has to do the things like statistics and curve fits and stuff like that. Now let's answer this question by clicking here and do new experiment. I'm not saving. And let's see, Tom, I'm going to say new experiment.
Okay.
And you have a choice of start new experiment or disconnect. Why don't you disconnect and then you'll have to join again. We'll just kind of start over.
Okay. So here I am disconnecting.
And I guess I'll have to come up with a new code, right?
Well, you're still data sharing.
Okay. All right. Try it then.
Okay.
That one.
So if I go to new experiment, and I don't want to save my previous work, and I'm going to go to data sharing. So I click on data sharing, and here I have to enter that key again, which should still be in the chat. I'm clever, I'll be able to find it. AIU 7XD. And connect. So that's the way the student joins the session. The teacher creates the session, or anybody can create a sharing session by using the data sharing icon, starting a session that way.
Right. Okay. We're running a little low on time. So here's what I'm going to do now. Remember I said this is a two-part experiment. The first part was to vary the current in the Slinky And we had a nice linear relationship. Is exactly what you'd expect. The second part is to kind of a fun thing where you actually change the length of the slinky. And this gives me a chance, since that would be a little logistically hard for us to reach over there and you couldn't see it very well. The fun part is I can show off another new feature of Graphical Analysis Pro, and that is, if I go here to New Experiment, in fact, Tom, if you don't mind, well, no, I'll leave you there because you can do the same thing. No, but I'll tell you what, no offense, but I'm going to take over the screen so people can see better. I'm going to do New Experiment. I'll just say manual entry, doesn't matter. Okay, I'm sorry, I didn't need to do that. New Experiment. What I want to show you is this thing over here, sample experiments. This was another thing we did to help with the pandemic situation. We made a whole bunch of sample experiment files with, these are not just sample data, but also the video taken while the data were collected. Now, this is a physics workshop, so I'm going to go to the physics area. In fact, I'm going to get something from the Physics with Vernier book. And now, I told you before, this is lab 26. It's a two-part lab. That's the part we just did in case you want to see it done again on video, but I'm going to show you the part 2 one. This is the second half of the lab, and we don't have time to really do it, but there's a video here, and watch what happens. I'll make the video bigger. So and these are all available to every student. So we're just showing still shots of the setup, and then that's the detail of the setup. And then this is as we change the length of the slinky, and we took data, and the data are off to the left. And again, you can say to the students, hey, there's the data, analyze it, answer the questions, and come up with conclusions. Okay, so anyway, we're pretty excited about Graphical Analysis Pro. We've used it a couple different ways here. And I think I'll call it quits and see about other questions. Are there some?
So some people looked like they were having some challenges connecting with it, but we got some good help from our attendees to give them some tips for starting the experiment over again and typing in the code again. So, and then there was a question about, can you do the same with teachers using Logger Pro, teachers and students using Logger Pro?
Okay, that's an interesting question. The answer is no, not exactly. Logger Pro, Logger Pro was started in 1995, and I think Logger Pro 3 was about 2005 we started it, something like that. So technology has changed a lot. We love Logger Pro. We'll keep supporting Logger Pro as long as we can, but it doesn't have the sharing kind of stuff built in. It certainly has video stuff built in. I guess you could, let me say, you could do the experiments file thing. You could collect data and collect a video and put the two together, and you can synchronize them and all. Incidentally, I didn't show, let me do one more thing real quick. I just thought of something. If I go to experiment again, don't save. I showed a sample experiment, but I didn't show a really great one because this events with entry stuff is a little not exactly exciting. Most physics experiments involve, data or something moving, and there's a synchronization between the data and the action. So let me show how that works with this a ball toss example. This is what we call the enable replay button. I've loaded one of those sample files from our collection. If I hit that, and now I can hit play, watch what happens. There's some introductory video stuff here. This guy's going to toss a ball above a motion detector. But watch, at the moment of collection, the data comes in live. We think that's a big deal. So again, nobody's going to pretend this is as good as the kid doing the lab, but we think this is not a bad, if you can't be in the lab, not a bad step toward getting the data, and you can remember every student has this as part of their their Graphical Analysis Pro. So, any other questions come in, Tom?
There's a question or a comment about using LabQuest to data share.
LabQuest has a different kind of data share. You can stream the data out. I think that, if I'm not mistaken, that's more meant to be done by Bluetooth in a local, like a classroom situation, but I am not really positive on that.
The other way you could use it would be to data share to students using their Chromebooks. So you might collect the data on the LabQuest and then use the data share for students to pick the data up.
But the students need to be in the same room. Is that true? Or?
Yeah.
I think
It's
that's the
going to
case.
be
Yeah.
basically a Wi-Fi connection or Bluetooth. Wireless connection.
Okay. All right. Well, it's been a half hour. Unless there's a last question here, I think we'll conclude this webinar. And thank you for joining. Thank you to Tom for helping, being both a good student and a good teacher helper. And thanks to Angie for coordinating things.